is to reduce the human imprint of energy consumption, right? We wanted to fulfill these energy needs of the population while also reducing costs with a new technology or system or machine to produce these. First, let's define fuel. A fuel is basically a material that has the ability to store potential energy to be later released into the environment as useful work for cooking or heating up your apartment. A biofuel is a subcategory of fuel that's made up of organic matter, which is made out of something that's living or was recently living, such as plants or fungi. There's a few varieties of biofuels. They have different applications, which we will later discuss. A couple of these are bioethanol and biodiesel. Uses, as I said before, include fuel in your car. Transportation is the biggest sector that uses these biofuels, and it has been for over 100 years. And cooking.
All right, now I'm going to explain to you different ways of converting biomass. There's thermal, thermochemical, chemical, and biochemical conversion. Thermal conversion is to utilize both heat and chemical to produce energy from biomass. Gasification is the most common of such methods, which is the application of large amounts of heat to convert biomass into useful gas. One example of that is coal. When you use coal, after burning it, most of the coal is turned into a gas. All right, now we're on chemical conversion. Chemical conversion employs chemical interaction to convert biomass into forms of usable energy. An example of chemical conversion is transesterification, where ester exchanges in an organic group with another alcohol. Biodiesel is a great model for transesterification. When glycerin is separated from fat or vegetable oil, in a process that reduces the viscosity of its fatty acid and makes it combustible. Now, biochemical conversion is the use of microorganisms to carry out chemical reaction. There are two techniques in forming and using biochemical conversion. There's anaerobic digestion and there's fermentation. Anaerobic digestion is the use of microorganisms without traces of oxygen to break down organic material. Fermentation is the use of yeast to convert carbohydrates to alcohol.
Modern use of biofuels has its advantages and disadvantages. Some of the advantages are cleaner energy, and it's a renewable resource, and it has a better impact on human health as compared to regular petroleum that we use, standard petroleum we use today. And some of the disadvantages are that it uses a lot of energy in order to produce biofuels, and it's very costly. And the more the sources for biofuels would have to be produced at a very great amount that is going to have an effect on the food market, and it might have an effect especially on the poorer side of the spectrum. And the two main biofuels that are used are bioethanol and biodiesel. And biodiesels are primarily in trucks and diesel cars, and you have bioethanol that are the ones that are used in the other vehicles, and it's usually made from sugar fermentation process. And as you can see, the amount of standard fuel being consumed is increased at a very high amount every year, and in proportional to biodiesel barely is being used year by year, but it's increasing. And in the future development of biofuels, the the process of biofuels can be improved by using biochemical and thermochemical technologies such as gas turbines, in order to have a higher energy output as compared to energy input, and a cellulose production, extracting cellulose energy from plants, and cellulose is a very good prospect to use for biofuel, as a source for biofuel, because it has a wider range of plants that can be used in order to create it, and it potentially produces over 90% less carbon emissions into the atmosphere, which is also good for human health, positive effect. And instead of the carbon going into the atmosphere, it goes into the underground and creates a perennial energy crops, which helps prevent soil erosion from happening.
This slide projects the production of cellulosic ethanol. In the next decade, BP is going to be a leader with 72 million gallons produced per year, and then there's all these other plants in production all over the world. By 2030, we should have about 250 million gallons being produced every single year.
In the proposed design, we have a gas turbine and a diesel engine working simultaneously, taking in biofuel, and in the design, the gas turbine will intake biofuel and there will be manipulations using reheat and regeneration stages that will make the gas turbine create more mechanical power in turn for a design in a car with a diesel engine, and it will be more thermally efficient that way.
In our conclusive slide, we want to leave you guys with a few points to keep in mind. First of all, you have to remember that biofuels have been forever, and they're going to keep getting used and just better to fit into our future. Remember that they're made out of biomass, which is the organic matter we discussed. These can be broken down into energy using a few different methods of conversion. Bioethanol and biodiesel are the most abundant biofuels, and these are mostly used in the transportation sector. In the future, we're looking at cellulose production by the masses, and hopefully it'll be providing us with a lot of clean energy. And most importantly, we want to leave you with the fact that this is a great alternative to our current status, where we use a lot of fossil fuels that are not environmentally safe. And that is our presentation. Thank you.